everyone, this is the final year students of 1620 batch TKMIT presenting our final year project on the topic Flood Modeling of Achankovil River Basin under the guidance of Ms. Devi V. And our group members are Adiba Shamsuddin, Anand Alex, Mohammad Anwar and Sri Lakshmi Israj. As we all know that Kerala had received severe rainfall during the last 2 years, that is 2018 and 2019. In order to overcome those pandemic situations, flood modeling has been proposed as a tool for the assessment of the flood risks. Achankovil River was one of those severely affected rivers during the previous years. Of that, Pandalam and the surrounding areas had been badly affected due to the flooding in the Achankovil River. Our project aims at developing a flood model along the selected reach of Achankovil River Basin. We have framed our project into 3 stages. In the first stage, we have prepared a digitized map of our selected area using QGIS software. For this, we had obtained the toposheet of Pandalam from the Nakshe portal, which is a national mapping agency under the Government of India, and we have digitized the regions of Kadakyad and Muttar that were badly affected during the floods. Now the second stage of our project was stage discharge modeling using artificial neural network done with the MATLAB software. It consists of mainly 3 layers, that is the input layer, hidden layer and the output layer. For our project, we had a single input layer, that is the stage values, and a single output layer, that is the discharge values. For this, we had collected the stage and discharge values from 1992 to 2000, that is 9 years data of Tumpaman gauge station maintained by the Central Water Commission. We had used 80% of data for training the network and remaining 20% for testing. Finally, we have compared the resulting test output with the desired output, and the best network architecture was chosen based on the network performance parameters, namely the least RMSE values, that is the root mean squared error values, NSE values, that is the Nash-Sutcliffe efficiency values, and the correlation coefficient values. On these basis, we have selected a neural architecture with 1 input layer, 5 hidden layer and 1 output layer. Next is the final stage of our project, that is flood modeling using HECRAS software. For this process, we have collected the cross-section details of the Achankovil River Basin from the major irrigation department of Koranjeri. In this step, we have selected a river reach and prepared a 2-dimensional cross-section with all the river stations along the reach. This is the 3D cross-section of the river station along the river reach, showing various river stations of the XYZ perspective at different azimuth angles. After performing the hydraulic computations using the discharges that we have found out using ANN, that is the artificial neural network, we have obtained this video showing the flow of water through different stations at a maximum discharge of 750 meter cube per second. We have also found out that the river stations 125 and 175 were the river stations that were most vulnerable to floods. Finally, we would like to conclude that Kerala, being flood prone over the past 2 years, needs an effective flood modeling process for each and every river basin. This helps in the assessment of flood risk and to identify the extent of flooding so that proper evacuation and mitigation measures can be adopted at the right place at the right time. Thank you.
Hi all, our topic is micromaterials. Myself Benita Biabru and my team members are Altaf, Abhinand and Rosanna, and we were guided by Ms. Nida Raj. Myco means mycelium. It's the vegetative part of fungus and it is obtained when the spores of the mushroom germinates. mycelium can bind and transform discrete particles into a physical composite. Our aim of the project was to obtain a lightweight, eco-friendly and cost-effective materials like microboards and microbricks, and also to prove that building materials from mycelium is stronger and resistant to termites and fire. For our project, the raw materials required were sawdust, which is a main component and it is used as the filler material, mushroom seeds, and here we used oyster mushroom seeds, Barvestin, which is used as a disinfectant against fungus, calcium carbonate to enhance the growth of mycelium, and bleaching powder, which is also used as a disinfectant. Our first step of the process was to prepare the molds for the formation of microboards and microbricks with mold size 35 cm by 35 cm by 5 cm and 22.9 cm by 10.3 cm by 6.9 cm, which is the same size of standard brick. It was then covered with polypropylene sheets, which is known for its excellent chemical resistance in corrosive environment and is clear enough to monitor growth. After several trials, we concluded that chemical sterilization is the best option to prevent contamination which is necessary for the growth of mycelium. The sawdust was immersed in water mixed with bleaching powder and Barvestin for 1 day. Likewise, molds were also sterilized. Then, the sawdust was taken out and drained. The sawdust and mushroom seeds were filled in the molds layer by layer. After completing the set, they were kept in a dark, clean and cool place. You can see the changes happening to them as days go on. This was the state after 2 weeks and you can clearly see the formation of mycelium over the materials. After this stage, the materials were shifted to Fogger room, where the temperature was set at 27 degrees Celsius to enhance the growth. The materials were hung in the Fogger room. You can see the closer view of almost fully grown microboard and microbrick. Approximately after 45 days, we were able to get the final product, microbrick. And due to the pandemic situation, we couldn't take any preventive measures against the contamination of microboard. Finally, the tests were done and we were able to prove that microbrick is stronger than conventionally used bricks. Further studies on how to grow mycelium effectively and how to provide favorable conditions has to be done, as this was the main obstacle we faced during our work. Microbricks are also lightweight materials, that is, it can float on water. Thus, we are concluding that microbricks can be effectively used as a building material in the future.
In the present scenario, improper stormwater management leads to flood and scarcity of water. The objectives are to study the various techniques of stormwater management, identifying the road proposed for study and development and design of suitable stormwater management system. The area is a road restricted to a road stretch of less than 1 km from Velappa to Pulikkamanal Junction. The methodology: identification of site analysis, study of existing situation, collection of data, design of structure, result and discussion. Site under study is Ayramthing Road of length 610 meter, width of the road 4 meter, which is single lane and having laterite soil. From Velappa to Mevur Culvert, which is of 280 meters, not paved. This is the site map, and we can see that up to a height of 300 meter it is paved, and runoff coefficient comes up to a value of C is equal to 0.275. Estimation of intensity of rainfall is selected as 45 cm per hour. We used 5-year return period. Estimation of runoff, we used the formula Q is equal to CIA and obtained 14.23 cumex. This is the dimensions of the storage tank, 0.5 by 0.25 by 0.25 meter cube. For the number of storage tanks, we use the formula Q is equal to NAC into root MI and we get 65 storage tanks. For the design of French drain pipe, we took the diameter of pipe as 8 inches. And for the design of GI pipe, we use the diameter as 0.5 meters diameter GI pipe. For the design of intermediate pipe, we use the pipe of diameter 0.025 meter. This is the estimation of drainage system, and it comes up to 37,42,270 rupees. Here we can see the cross-sectional view from which the storage tank, which is placed at intervals of 9 meter to the adjacent storage tank, from which is connected to the French drain pipe of diameter 8 inches, and the storage tank is connected to the French drain pipe via intermediate pipes of diameter 0.025 meter. The storage tanks are connected to each other via intermediate pipes, from which the water flows from the precast tank into the pipes which is situated at a certain level above the tank so as to prevent sediments from entering the tank. The water from the road thus flows into the storage tank in a quick and effective way, thereby preventing water being stagnant and prevents flash flooding. The French drain pipe is a percolating pipe which allows the flow of water into the nearby canal so that the water which is flowing through the storage tank can be directed into the canal through these percolating pipes. We can see that this is a quick and effective way to remove the runoff water from the roads into the storage tanks and effectively utilize them in the nearby future. Thus, we can conclude that the waterlogging problems can be managed efficiently and effectively using the water storage system. The previous issues which persisted for 3 to 4 days are estimated to flow within a few hours through the French pipe with the implementation of the proposed design.
We would like to introduce our project Amphibious House, an innovative strategy for flood resilient housing. The team consists of Anjali A, Kavya Y, Rasni A, and Vishnu S. Prakash under the supervision of Assistant Professor Ms. Roshni Roy. Floods are one of the most common hazards in the world which causes fatality, harm to livelihoods, and property annihilation. In August 8, 2019, a devastating deluge has arrived in Kerala. A large chunk of area has been evacuated as part of rescue measures. So, we have got a new idea of amphibious house which basically targets the concept of flood-resistant house. The objectives and scope are well explained below. To overcome difficulties with floods and to ensure safety of life. Provide sustainable, economic, and environment-friendly structure using lightweight materials like GFRG panels, PVC partition walls, EPS blocks, bison panels, and aluminum sheets. Prepare a single-storied amphibious house to solve the problems of extreme flood condition in Monroe Island. To implement this strategy, we have selected a plot in Monroe Island, which is otherwise known as Sinking Island of Kerala. It is one of the astonishing inland island groups located at the confluence of Ashtamudi Lake and Kallada River in Kollam.
However, major problem arises with the settlement of structure due to heavy concrete materials. In order to compensate this, we adopt lightweight materials. Let's move on to the methodology. Site selection, analyzing the soil type, rainfall data and flood details, fixation of plan in AutoCAD, fixing materials for structure and load calculation, and software analysis. This shows the plan we created in AutoCAD having an area of 500 square feet. The team has also done a software analysis with e-tabs and we have pinned the here. This is the BMD and SFT diagrams of structure. It conveys the bonding moment and shear force of this structure was less than that of conventional structure. Therefore, it is safe. Here's a 3D modeling depicting the scenario before and after flood hit. Let us watch a short video using 3D Max software. We can see that the structure rests on ground initially, and when the deluge arrives, the vertical guidepost established at the four corners of the house guides it to lift up. EPS blocks at the bottom portion acts as a bind material. Finally, conclusion and future scope. Amphibious construction is a low-cost, low-impact flood protection strategy with lifting mechanism. Provides greater resilience to house during rising floods. The concept can be elongated into greenhouse being able to use essential requirements. We can increase the number of story of infrastructure, also making necessary arrangements for the parking management of vehicles. These are the references. And finally, thank you.
Hello everyone, thank you all for being here today. To start with, we know that the sustainable development with higher strength is a growing demand of construction industry. Concrete reinforcement by natural fibers are more promising to ensure the concrete strength improvement with non-hazardous impact on environment as well as the effective use of available natural assets. Keeping this in mind, we actually came across a plant called crotalaria, which was abundantly available in our region. Since it is available in plenty and it almost looked more like an unwanted species of grass, why not we extract fiber from it and make use of it in concrete? Thus began our project, an experimental investigation on crotalaria fiber reinforced concrete. Me and my teammates are hereby to present to you about our final year project. Fiber reinforced concrete is a concrete made primarily of cement, aggregate and reinforcing fiber. Fibers suitable for reinforcing concrete have been produced from steel, glass and organic polymer. The natural fiber we used was extracted from crotalaria plant, which had amazing properties like lignified fibers in stem, more durable than jute, high tensile strength when compared to jute fibers, have more strength when wet, resistance to fungal attack, etc. The main objective and scope of our project is to develop crotalaria fiber to reinforce concrete composites to investigate the effect of volume of fiber on the mechanical behavior of concrete. Crotalaria fiber reinforced composites would be one of the promising strategies to improve the performance of concrete. And we had followed a very strategic methodology to complete our project. First step was material collection, then processing of materials where the fibers were cut short with respect to the aspect ratio fixing. The further steps were testing of materials arriving in mixed proportion, quantitative estimation, casting and curing of the test specimens, and that cubes, cylinders and beams were casted with the addition of fibers in varying proportion of 0%, 0.25%, 0.5%, 0.75 and 1%. The next step was testing of the specimens. An attempt has been made to determine the compressive strength, split tensile, flexural strength and water absorption test. The last and the final step was result analysis. And here we have some pictures of our fiber, the testing procedures, the cracks on the cylinders, etc. And now moving on to the most important part of our presentation, that is results and discussions. Based on the test results and analysis of plotted area fiber reinforced concrete with the conventional concrete mix, we conclude that plotted area fiber reinforced concrete have comparatively more compressive strength at 0.5% fiber addition when compared to the conventional concrete mix. Plotted area fiber reinforced concrete have comparatively more tensile strength at 0.5% fiber addition when compared to the conventional concrete mix, and plotted area fiber reinforced concrete have comparatively more flexural strength at 0.75% when compared to the conventional concrete mix. The results indicate that there is an increase in compressive strength, split tensile and flexural strength with respect to that of plain concrete varying from 0.25, 0.5, 0.75 and 1%. However, for a particular mix, there is an optimal volume fraction of fibers that will give the maximum strength. In the case of mixes tested in this investigation, the optimum percentage of fiber was 0.5%. In general, it may be concluded that on increasing the percentage of fibers in the mix, the strength increases much better than the conventional concrete in most of the aspects, which can be due to a variety of factors like characteristics of the fiber, nature of the cement-based matrix, the way of mixing, casting and curing of the composites, etc. And the use of this plotted area fiber in concrete can reduce the total energy consumption of a construction project and will contribute to sustainable building practices. Last but not the least, the use of fibers can definitely ensure the post-cracking resistance, high energy absorption of features, and increased fatigue resistance of cement-based composites. So the future scope of our project turns out to be casting and testing of the steel reinforced concrete beam with and without plotted area fiber for studying the effect of fiber in reducing the cracking behavior of concrete. And that brings us to the end of our presentation. Thank you very much.
Project is about fiberglass mesh reinforced foam concrete. Foam concrete is a lightweight concrete which uses only less aggregate and has low density as compared to ordinary concrete. They are generally used for non-structural applications like void filling and other repair works, and not widely used for structural applications as normal reinforcement like steel cannot be used in foam concrete since it contains voids that contains air which will corrode the surface of steel, and at the same time the lightweighted properties of foam concrete also changes. So there is a need for providing reinforcement for applying this into structural uses. So we come forward with an idea of fiberglass mesh reinforcement which is light in weight and at the same time provides strength and non-corrosive in nature. We also provide partial replacement of fine aggregate in which the natural resources are depleting day by day and there is a need for minimizing the use of natural resources. We had used natural forming agent rather than synthetic forming agents like CFC because natural forming agent had formed more denser form as compared to synthetic forming agent, and at the same time they are not very expensive as compared to synthetic forming agent. First we soaked the softnet, say 20 to 25 number, into 1 liter of water for 24 hours and then heated at a temperature of about 100 degrees Celsius for 10 minutes. Then the solution is allowed to cool. The solution is then agitated by using mixer until stable dense forms are generated. We had found out an optimum percentage of fine aggregate replacement, that is 7.5%, which has strength as compared to the normal form concrete and thus higher strength is attained at a lower density. Then we provided fiberglass mesh as reinforcement, thus found about 77% increase in strength due to its higher binding between them, and also ductility of specimen as a whole increases. Future scope of the project is that durability test for this project has to be done for its applications on areas like manhole cover, and then thermal resistance of the specimen has to be checked because thermal insulation properties ensure the energy conservation and other ecological problems.
Lightweight concrete with RBB and BDM. In India, around 25,000 tons plastics were produced per day. The versatile behavior of plastic makes it suitable to be used in concrete. Plastic is a threat to the environment. This study shows the possibility of replacing coarse aggregate by RPB and fine aggregate by crushed BDM. Utilization of waste plastic and construction waste is a partial solution to environmental problems. Our solution for these problems is to partially replace coarse aggregate by RPB and fine aggregate by BDM in concrete. Objectives: comparative study of plastic aggregate in M20 concrete to find the optimum amount of RPB and BDM to be used in concrete. Methodology we followed. The strength of concrete prepared using RPB was found decreasing. As strength is the main factor of a construction material, we cannot compromise it. Alternatively, we thought of adding some additives into the concrete. BDM, which is a construction field waste, was added into the concrete. The strength was found to be satisfied. The optimum amount of BDM was concluded to be 20% of fine aggregate. The combined concrete with RPB and BDM was formed, and the strength was found quite satisfactory. It was found that the concrete provides thermal insulation property. If we want energy efficient alternatives to air conditioning, you need to stop the heat before it reaches inside your home. It keeps your home warm during winter and summer too. That is, protects inside of your house against outside temperature. That provides comfortability. Results: the addition of RPB decreased the compressive strength of concrete, and for regaining strength an alternative BDM was used. The optimum amount of RPB was found to be 25% and that of BDM was found to be 20%. Conclusion: effective replacement of RPB and BDM into concrete thus provides a green and cost-effective building material. Overexploitation of natural resources can be reduced. Energy efficient building can be built, thus making it cost effective. Usage of recycled plastic implements 3R concepts. References:
Retrofitting of RC beams using steel fiber mesh. Retrofitting refers to addition of new technology or features to older system. It is an improvement over the original strength when building undergoes damages. Jacketing is the most popular method and it enhances the shear strength and flexural strength. The main objectives of this project is to find the strength of structure after placement of steel fiber mesh and geotextile. Cracks are formed due to increased loading in building. These elements can be strengthened with the steel fiber mesh and wrapped with geotextile sheet using epoxy resin. Then various tests are conducted. The methodology includes collection of raw material, casting of RC beam, curing of RC beam, wrapping of RC beam with steel fiber mesh and geotextile, and testing. The main properties of steel fiber mesh is ease of installation due to the lightweight and ease of adaptation. It is also easy to handle and storage. It has high environmental stability and no toxicity. After conducting various material tests, we have arrived at a mixed proportion and we have casted 9 beams. These beams are tested under UTM. After this test, the specimen retrofitted with steel fiber mesh and geotextile has more strength compared to other two types of beams with beams. So the experimental result confirms that strengthening using steel fiber mesh bonded with beam performs well, also enhances the carrying capacity of RC beams.